Well, welcome back. And today we're going to be looking at, over here we have the KA3305D. So basically this is the equivalent to this one, but the updated version. This one's been discontinued. This is the new model that they brought out. And all in all, size comparison, well, there's a little bit of a difference in size comparison. This seems to be your standard 16-inch depth, where most of the other equipment that you have on your bench is probably the same depth. This one was kind of cut short. So you can see there's, in fact, let's just take some quick measurements here. Yeah, I would say about 15 1/4 after the posts, compared to almost 10, oh, after post, sorry, 11 1/2. We got 10. 8 3/4, and let me see the height. I'd call it 6 1/4 versus 5 1/2. So little differences, not much. All in all, the handles are the same handle you expect to see on the other one to support the weight of the very, very heavy transformer. One thing that I didn't really care about this one, although it did a great job keeping up with the power and everything, is the parallel and series mode. If you're not familiar, or if you don't do it often, sometimes you'll forget how to put it in there. It does support it. Actually has a relay. These are actually two smaller power supplies joined together with a crossover board and a relay to actually join them either in parallel or series to work together. So what I ended up doing is there was no markings here to tell you where the parallel and series were, so I ended up actually printing part of the manual out and keeping it under the handle. A tip for you guys that may actually own one of these right now. Now, on the other hand, over here they actually added some extra writing. It actually notes which two posts are used when it's in series mode and which two posts are used when it's in parallel mode. Did I add that right? Sorry. Which two posts are used in parallel mode? No, that's what I just said. Try it again. Which two posts are actually used in series mode are these two, and which two posts are actually used when you put into parallel mode. Similar operation. You hear a relay click joining the two power supplies together, but they're not two individual units. This is actually one unit altogether. Now, I'm sure everybody's seen the inside of this one. It's just notorious. Several videos out there, breakdowns, several revisions, fixes, what have you. As nice as this one has been, I was actually very curious about this one, because there's been some very nice high-def pictures taken on the EEVBLOG, so there's been some really nice teardowns and everything, and there's been comments made. Nobody's really done a video on it per se yet, so I figured I would grab it and do a video, show you what the difference is real quick. The specs are pretty much the same. The control interface is slightly different, where because these were two individual power supplies together, you had a separate control interface for this side and a separate one for this side. This one had a third post on this power supply. Actually, it was a 5-volt 3-amp constant, unswitchable, unadjustable. Same thing here, 3-volt 3-amp constant, unswitchable, unadjustable. This one has multiple ground rails across it, so you don't have to plug in two wires and then try to throw a ground all the way to the far right or to the middle from where you're at. Nice little touch, but again, one control panel for all, so the interface is a little different, especially how you change between voltage and amperage. For example, we can turn this one on here. On this one, you're used to hitting your voltage current control button, and that will change you from voltage to your current, and you can adjust the cursor to where you're at for what you're looking to change. You can go back up and adjust the cursor here and do the same thing. So that's kind of what everybody's used to seeing all the time. And then of course individual on and off for each side. And the same thing goes over here. You have your own control panel over here, and of course as you adjust the voltage, you'll hear the relays kick in and out through different stages of the power supply. And you turn it off. And right here, you can actually hear the fan right here. So if you can hear the fan right here, you can just imagine what this fan would be like if it was under load, or, I don't know, per se, dead short. Let's go for the dead short concept because it's just easier for right now, just to kind of get the fan ramping up so you have an idea of what that fan sounds like. Is that going to show up on there? I guess it probably doesn't really matter. So if I was to set this to oops, I meant to go over 1. Missed it. 5.1. Take it all the way up to, well, got to get that down to 0 before I can change it at that level of resolution. 31 volts, and turn that on. Instantly the fan ramps up, 5.116 amps. Let's go ahead and turn this one on. In case you missed that, I'll do it again. Let's go ahead and turn this one on. Yes, that's what you hear. Nothing. There's just no sound there. Eventually, as it warms up, you start to hear a little click. It's actually temperature monitor controlled fan. It's a single fan, where this one has 2 fans controlling 2 different power supplies, 2 different sizes, 2 different units, and a constant RPM even when it's not putting anything out. This one has a temperature module where all the MOSFETs and all the channels are actually tied together and onto one big heat sink, and it monitors the temperature of that and controls the fan for that, and has a very unique way of blowing down on the heat sink and blowing the air out the back. And, well, very quiet. Does it ignore that fan? That fan is this honking transformer that actually kicks my circuit sometimes, and my UPS kicks in to kind of compensate for it. It senses a draw load on the circuit, I guess, in my house. Funny thing is, I don't have anything else really running in this room right now either, but the way my house is wired is the whole upstairs, So let me grab a 100-watt resistor here, because I do want to see if I can get this fan speeding up a little bit here so you can kind of hear what it will be at max. But to do that, I need something to eat up that power. So here's a 100-watt power resistor, 1 ohm, rated 1%. It's a dill resistor. And it stays cool. I should be good here. Come on, heat up. Get spinning. There you go. Now you're starting. There it goes. Amazing how quiet that is. I believe that's as loud as it's going to get. Right there. It's hardly anything. But you have better cool down off of the components, off of the power supply after using it under a heavy load. Has a nicer cool down to it, step down, which should, in theory, heat is your enemy when it comes to components of any electronics, right? So that should, as long as you remember to turn it off here first, let it cool down, and then turn it off here. But anything under 300 milliamps, this fan doesn't really move at all. So for low power application, it really is nice and quiet. Advantages are the amount of power it can deliver, how quiet it is, versus the let me move this out of the way here at this point. So you got the amount of power it can deliver. You got a triple power supply. How quiet it is versus the cost. Now the controls, I should note, are completely different as far as controlling it. For example, I'll show you real quick. You select your channel 1, channel 2, and channel 3 again, dedicated 5 volt 3 amp, no change. Let me pull the mic down here. So the controls are actually a lot different. I got such a flicker on this. I should have turned on the anti-flicker first. Sorry. I do not see this flicker in person. This is only on the camera. It's probably too late for me to turn on the anti-flicker and then redo the whole video, so I'm just going to leave it. But the controls themselves are pretty much, you select channel 1, and this is your voltage selector. It's a push button. You push it in to change the digit you want to change, and a knob, turn to increase and decrease. The beep isn't quite as annoying as the older one, I'll give it that. That's an improvement. And then you select channel 1. While you're over here, if you don't let it time out, you can move over to your amperage and select your amperage as well, as far as how much current you want to put out on it. Now, you can go to channel 2, you do the same thing, and channel 2 as well to drop the current. One downfall compared to this one in the older model is the other one had individual on and off for channel 1 and channel 2. When you turn this on, you're turning both on. You're both live. So keep that in mind. Don't keep something plugged into channel 2 thinking it's not going to be operational, and then set up something on channel 1 and turn the power on. That is kind of a downfall, I guess, in this particular model. The fact that it does one on-off switch, and it turns both channel 1 and channel 2 on, and of course channel 3, as I've mentioned, is constant live 5V 3 amp. So not quite sure how I felt about that at first, but I find if you follow standard safety practice procedures to always unplug the project once you're done with it before plugging in a new project and setting up new variables, then you'll be fine. Otherwise, you could end up blowing up some power inverters or whatever you're testing at that time because you forgot to unplug something and set it to 31 volts and it wasn't supposed to be more than 14. We have our standard menu memory 1, 2, 3, 4, and 5. So there's push to hold, which is lock. Now your keypad's locked. Now you're unlocked, and you have control over it again. You have push to hold over here to turn off the beep. If you choose not to hear the beep, you don't have to listen to the beep. Just like the other one, they gave you the option to turn off the beep. Perfect, good, gone. I prefer no beep. Or maybe sometimes I prefer a beep. Overcurrent protection and overvoltage protection do work fine. I've tested both of them. You hold it in to set your overcurrent protection. You choose the channel where you want it to be. You don't want it to be more than 14.5 volts, 5 amps. Perfect. And then you hold it down again to enable it. You just hit it once. Over voltage protection enable, just hit it once. To set it, hold it down, it comes up over voltage protection setting. You choose your channel, you change where you want that voltage protection to be set at, and you hit it again, and then turn it on. There you go. Now we have our over voltage protection set to 14.5 and 5 amps, channel 1. Okay. Oh, let's go ahead and set channel 1 up. To do that, 14.5 at 5 amps. There we go. So now channel 1 is set up for 14.5, 5 amps, which should be enough to drive this little power inverter that I blew up a while back. I will try to find that footage. I'll put it at the end. You can watch a bunch of capacitors blow up. This has an annoying beep to it. Sorry, there's no way to disable it. Last time I had it apart, I should have torn the piezo buzzer out of it, but I didn't think about it. And I only use it for testing loads and what have you. And here we got a 60-watt bulb. I'm going to put this kind of up on the shelf out of camera view. Otherwise, it's really going to mess with the white balance and probably annoy a lot of people watching the channel. But you'll still see the light come on and off as I engage and disengage the power on this. We'll start off with neither overcurrent or overvoltage protection on. We're set here, single channel plugged in, channel 1 only, 14.5, 5 amps, that's what they're set to. And you can see it's providing the 14 volts. Switching between constant voltage, constant current, because the way this inverter works, you saw the light come on, maybe not as much as if I was to turn this light off. You should see the light difference there. Yeah, you see a little glow. Let's bring the light down a little bit more. Maybe I had it too far out of the camera view. Maybe my camera will compensate better for it than I thought. Ah, it actually does a good job. Not too bad. Now, one thing I did notice with this one, on the overcurrent protection, I remember I got it set for 5 amps. I do not trip it. If the unit is on, and I have my overvoltage protection on, it does trip it. So while it's flipping back and forth between its constant voltage and constant current, it does slightly pull a little bit over the 14.5, and the unit does what it's supposed to do. If it goes over 14.5 volts, it shuts down. Over voltage protection, that's what it's for. How much is it going over? I didn't think it was going over too much. Initially, when I discovered this, I had over voltage protection set. We'll show you again. It is set for 14.5. And initially, when I did this, it was during the power on, which you can see just flips on for a second and shuts right off. It was really fast. So the protection circuit seems to be very fast, very good. I have no complaints there. What else did I have set up here? I had this guy here for a full 30 volt draw. This is a 100 watt LED. It runs 30 to 36 volts, I believe. And this will probably draw close to about 3.3 amps, I think, at about 31 volts. So let's go ahead and set channel 2 up with 31. Oops, I gotta get rid of that little one before I can go over to 31 volts. And we'll give it everything it can take, actually. We'll give it the full 5.1. And I'll go ahead and just double check, because I had this set on the ground, make sure I'm not shorting out here or anything. I got some heating compound on this honking heatsink here. I pre-staged this before setting this up. I'm going to set this somewhat out of the way. This is really going to throw off the white balance, so, you know, close your eyes. Let's see, it's turning her on. We're in the right channel. We're set up right. Yep, looks good. Yeah, 3.5 amps, 3.6, 3.7, 3.8, 4 amps at 31 volts, 4.2. It's almost hitting full load. Look at that, 4.5. Wow. Now, I haven't tested this heatsink, so I'm going to let it go to 5, because that's what it's rated for. It's rated for 5. That's, okay, there it is. Full power. Now we're on constant current, and I'm smoking an LED. I told you I didn't test this heatsink ahead of time. Jeez. Alright, well, not like I had big plans for it anyway. Whoa, look at that. That heating compound. Whew, that just kind of melted, didn't it? Let's go ahead and get that back on the heatsink. I saw a little smoke coming from the LED. I'm just blowing things left and right. I'll show you the video at the end, blowing capacitors here. I'll show you, well, I don't need to show you that. You saw that live. You probably saw a little bit of smoke coming off of this cob. My guess is probably just the outer layer of the cob piece. I think it'll probably be fine. It's not like I actually had this screwed down to the heatsink. You know, I just kind of pasted it in place. I already knew that wasn't the best solution, but I wasn't planning on letting it run to a full load to switch over to constant current. I didn't think it would, actually. I was surprised that it actually went there. So, surprise on me. Let's go ahead and... what is that? 3 point? I can't see because I was looking at the darn LED when it came on. But yeah, LED's still good. I think that was actually just a little bit of the thermal paste smoking and burning up. So we're still good. So there you go. And I don't have anything to really put this into a parallel mode to show a full 10 amp draw. I did do that when I first got it. When I first received this unit, and when I first got the other unit, the older unit, I actually did try that. I had 3 24 volt heatsink beds hooked up together in series, and basically what I did is wanted to see if it would get close to drawing the full 10 amps, and it did, and it ran for a while too, because I need to get all 3 of these heat bed plates for 3D printers up to a certain temperature before I knew that the soldering welds were good and it was going to hold. And I got to that point, and you gotta love it when monsters just find their way into the video. Thank you. And so I have maxed this out at 10 amps at 24 volts in parallel mode, and I just like I did the old one when I first got it, I did the same thing. Unfortunately, I don't run these heat beds right now currently to do that demonstration live or on this video for you. So it's just, again, one of those things you're probably just going to have to take my word for it. If you know me by now and you've been watching my channel by now, I do very in-depth reviews. I do not open something up and review it a week later. I play with it for a few months before I do a review. And I've had this one for a few months. You may have even seen it in the lab update videos as far as 2.5 months ago when I was transitioning one lab to another. So this is one of the things that I have been working with and playing with for a few months now. in the hopes of saving some time, I already have this completely unscrewed for you. Look how easy that was to take apart. Amazing, isn't it? I had screwdrivers for my fix-it. Done. Real fast. Didn't even see me take it apart, did you? No, of course you didn't. So inside is absolutely clean, and here's what gets me: the control boards look identical, almost identical, except they're a single board instead of two boards. But the control boards look almost identical. And if you've seen the high-def teardown video photographs that are on EEVBLOG from a different user, you've already seen the inside of this. But the control boards look identical as far as the unknown hidden mystery processor that's been lasered off. Ooh. Or at some point, actually, they actually had the chip manufacturer for the processor, for the microchip processor, actually put KORAD on there at one point. Single circuit board instead of two different power supply boards. Single fan here. Very, very clean. Very wires set up out of the way. The main switch coming in here to that main hard down, power up and down. Has that extra protection here for any extra heat that may be being thrown from the transformer. Honking big transformer here. Extra cables and plugs for additional features. Some female plugs over here for additional features. I do not have the USB port on this or any of the additional options that you can get for this. This is your basic 3-rail power supply. The heat sinks and everything seem to look pretty good. Let's go ahead and put it on the side. Real big capacitors. Of course, they're labeled Rubicon. Does it work? Yes. Has it worked for the last 3 months? Yes. Have I tested it as fully as I could and actually give it a heavy load and give it a workout? Yes. Power per dollar, watt per dollar. It's a nice unit. Some of the features I thought were really nice on it, you know, being able to cool down the components before it actually shuts the fan off all the way. Kind of gives me the suggestion and hint that longevity won't be an issue. The components should last longer and better. Stability should be good, and a really nice clean unit. For home hobbyists like this, I really think it does deliver a nice power, you know, wattage per dollar, I'll call it. I think it does a really good job. Thanks for watching. Please give it a thumbs up if you like this video. Don't forget to subscribe and enable notifications so you're aware of new videos that I release going on in the future. And keep on tinkering. Between channel 1 and channel 2, honestly. So, but these are both 30 volt 3 amp channels. Granted, this is, you know, 30 volt 5 amps. Technically, this says 3 amps, but it's 3.2. Now, maybe that's the problem. Why do they give you a 5.1 when they advertise it's a 5 volt power supply? And they say it's 30 volts, but yet they let you go up to 31. And over here, they do the same thing. They said this is a 30 volt 3 amp, but yet, let me see. Still trying to get used to this. So I think if I put 31 volts in there, yep, it gives it to me. As a matter of fact, here it tells me 32 volts is my maximum. So it even tells me that I can do 32 volts. I'll be darned. So there's my maximum. And then yet for the current, they say it's a 3 amp, but it's allowing me to do 3.2. So let's say, hypothetically, whoops. No, I don't want to do that. Let's just give it 3. So if I give that 3, and I give this 3, nope, not what I want to do. Oh, I do like that though. Here I can actually tell it amperage or milliamps. That's kind of nice. Okay. So I go to voltage, current. I was on my overcurrent protection is where it was at. So I give this 3. And now they're both saying 3 amp, 3 amp. Overcurrent protection I need to turn on this channel. And we'll set this for 3.199. And on this channel, we'll do the same thing. Well, 3.199. I can't do that. That's not right. What am I thinking? I'm not thinking right now. Let me. It should. We'll do maximum draw of 3.1. So it's only set for 3 amps, and if it manages to kick 3.1 out, it should trip. And I know it's kicking 3.2 out. At least that was measured off channel 2. So same thing here, 3.1 on the overcurrent protection. Let's move it back over. Charged up, good to go. I'll let this come down to about 118. Take a few seconds for the bigger caps on the back side to charge up. Close enough. Oh, it says it's drawn exact. I see 3 amps running across there, so it says it's putting out exactly 3. I'm pretty sure if I go online again, I'm going to prove it wrong. That's actually putting out more on surge. Whoop! There it goes. Fuck. Well, that wasn't even on. That could have